All right. So this is a copy of your project, which we've been looking into. Your setup is as follows. You have an area of interest in this area near Weerselo, apparently.
Yep.
You have this waterway, which is of interest to you because you want to have water flowing through it, optionally blocked by a weir in a certain location. The idea being that the weir will block water behind it, yes, and cause some backflow in drainage underneath this field.
Yeah, not especially drainage, but also without drainage. I want to test if the weir is working properly and that the water is going into the groundwater.
All right, very good. This is a copy of a project in which I've been able to experiment a bit already with the things in your project to see why you were seeing the things that you were seeing and not seeing the things you were expecting to see. Most important is the weir in this regard, because the weir has to block the water flowing through this waterway, ideally so that water may start backflowing or at least build up in this part of the waterway. What's important to test that phenomenon is the ability to read out what the actual water levels in this waterway are. I saw in your project you have a number of overlays which are mostly configured to display information related to groundwater levels. And the main result type of your water overlay was the water stress result type. The water stress result type is does look at surface water levels, but in some cases may obscure what you're actually trying to see. The two result types that I would recommend for most use cases are the surface lost value, or if you really need to know maximum heights, the surface max value. The surface lost value means as much as, for any given time frame, what's the water level at that point during the simulation. And the max value means what is the highest water level that has been seen thus far. Which means that if there's a big wave, there's a meter of water flowing through and then it dies down again. The surface lost value will show in the progression of the time frames the water increasing and then decreasing again. And the surface max value will show the water increasing and then retaining that maximum value that it has seen for the remainder of the time frames. The water stress is basically the same as the surface max value, except that it also takes into account a certain amount of allowed water increase on the water. If the amount of additional water in a waterway is less than whatever number you've entered here, then there are no results displayed on that waterway because it's not stressed yet. On land it would be stressed immediately, but waterways are designed to have some buffer capacity. And it's only when that capacity is exceeded that it starts showing results. But for the purposes of knowing what the water does exactly during your simulation and effectively debugging why certain water flows do or do not work, the water stress, I would not recommend that one. I would use the surface lost value, or in this case, the one that I've selected, because it also relates properly to groundwater levels, is the surface lost datum, which is not the height of the water on the land, but it's actually the height of the water related to the Dutch datum, NAP. So I've added the surface lost value result type to display the height of the water in the waterway. And this allows me to place a measuring line in your waterway, showing the height of the water in that waterway. Now the peak you see here is the elevation that you've drawn in manually over the weir, which is okay. for any land obstruction in the waterway, you will see that it shows this kind of a peak. But you can also see the water levels around that elevation increase, which are the water levels in the actual waterway. And as the simulation progresses, you will see that water levels in that waterway will increase slightly. And this allows you to see what the water levels are right in front of the weir and right behind the weir, or the other way around, depending. So this is an important tool to debug your simulation if it doesn't do what you expect. And B, I think this is also one of the tools that you are going to need if you want to see what are the effects of my weir on the water levels, because this allows you to actually see the effects on both sides of the weir.
Yes, that's very clear.
And what I've seen by doing this is that your weir was configured at a height of 22 meters relative to datum. So that's about this height. And the water level around it was actually increasing to above 22, which means that water can easily flow over the weir. So then, yeah, it doesn't have as much of an effect because it's basically submerged. Water is free to flow over it. In this simulation, I've slightly increased the height of the weir. I've increased it to 24, which means it's actually about this height. So water is actually blocked behind the weir.
Yep. But isn't it higher than the ground level on the both sides? Where?
The weir height is now higher than the water level on both sides, and it's probably also higher than the terrain heights on either side. But at a very minimum, if you want to know if your weir has an effect and you're looking for the kind of effect that's about saving up backflow effectively, also in the time scales that you're looking at and the complexity of your situation, you're basically looking for, is the weir stopping water or not? And if it's submerged, then the answer is no. So its most important factor will be, is the water higher than the weir or not? Or is the weir higher than the water or not? And if that would also mean that the weir is higher than the land, or that the water is higher than the land, which kind of implies the other, then you're not just looking at the water flow in a waterway with a weir inside it. You're looking basically at the flooding simulation, and you're not the fact that the weir is there is not as much relevant. So far, so good?
Yes, it's clear.
Very good. As an aside, I also wanted to tell you, you have your weir configured here. And you've also increased the elevation model here so that there's an actual physical blockage in the waterway. This is correct, because if there's a weir somewhere, it's basically a connection between 2 points. And by blocking the rest of the waterway, you're preventing water from flowing around the weir. Effectively, you're forcing it so that it can only flow across the weir to the other side of the waterway.
Yeah, I saw that on the wiki that you have to height in the ground to work.
Yeah.
So it's just like a culvert, only you have a height that you can change.
Exactly. You have the culverts are usually indeed placed in places where there's actually a physical terrain blockage in the waterway. These are not the proper hydrological terms, I'm sure, but you get my point.
Yeah.
But weirs are usually placed just somewhere in a waterway, which means that for our technology's sake, there needs to be a blockage in the waterway added. However, you've also added a Weir Angle to the weir, which actually ensures that the water module already makes that blockage for you. I've added an additional weir over here to demonstrate this. If you add a Weir Angle to a weir, it will actually draw this obstruction which is a visualization in the 3D world, but is also an actual blockage as interpreted by the water overlay. If I make another selection and I activate the ground height result type of the overlay, you will see here as well that there's the height of the water bottom. And then suddenly here, the height of the weir itself, it's peaking up. It's not exactly those 5 meters, but that has to do with the rasterization properties. But at the point where the weir lies, it's the height is increased automatically. And our software is able to do that because it knows under which angle the weir is positioned, and therefore in which direction to draw that elevation increase. So if you use a Weir Angle, you do not need to add an obstruction manually anymore.
Okay.
Having a manual obstruction is not per se a problem. It's how we used to do things. It's just a bit of pollution in your elevation map. Doesn't need to be a big deal if you know what you're doing. But with this trick, you can avoid it.
Yeah. Yes.
Another thing you were looking at is you want to compare 2 situations, namely a situation with a weir, with.
Yeah, actually, without. So
Without?
nothing, no drainage, no weir, and then one with a weir to see what the weir is doing to the groundwater, and then add a drainage to see if the drainage helps to fill the groundwater level.
Okay.
Like a faster groundwater level, yeah, going up. That's because the farmer there, he built a weir there, and I want to see what the weir is doing with the groundwater level.
Okay. So you're looking at situation without a weir, you're looking at situation with a weir.
Yes.
Which means comparing 2 situations in Tygron. Well, Tygron is eminently fit for that. The only question is, what are the best ways to do that?
Yeah.
And for the weir, there are 2 ways that you could do that. One is you could draw in a situation in the current situation as it is right now, with a weir or without a weir. You can perform the calculation. Calculations have already been performed. And you can then save the results of a specific overlay as an inactive copy. You can do that with the Save Overlay Result button. It will add an additional overlay to your project. In this case, named whatever my overlay was named with the word copy behind it. And this overlay is then set to be inactive, meaning it doesn't automatically recalculate when you make changes and press recalculate. It will retain the results it has right now.
Okay.
You can then change the whatever you have in the current situation and recalculate your normal overlay again. That will lead to different results. And you will be able to compare the results of the latest calculation and the results of the stored copy side by side, or via the measuring tool by adding one as your primary readout and the other one as a comparison for it. We don't see a difference right now because I haven't actually changed anything, nor have I recalculated, but you can select both. And if there's a difference between the 2, one will be displayed as a red line, the other will be displayed as a yellow line. You will have your difference.
Oh, yeah.
So that's one way you can do that. You can create an inactive copy of a calculation that you have already performed.
And you can have multiple, like 3 or 4, or only 2. Yeah.
You can create as many copies as you like of as many overlays as you like.
And you can always also see that in the measuring tool, like that you have 3 lines, different lines, or.
The measuring tool can currently only combine 2 lines at the same time. So I can have, for example, my surface loss value relative to datum and my actual datum. Those are 2 lines I can show side by side. Mm-hmm. I cannot add a third one to this. It shows 2 lines.
Okay.
And as a small asterisk, I've said that there's effectively no limit to the amount of overlays that you can create copies of. For larger projects and for larger amount of overlays and for more detailed grids and thus for more data, at some point there is a limit to how much data we can have in one project or allow in one single project. Which has to do with the physical storage of the project, keeping everything in memory, things like that. But that's generally a limit you will only encounter when you're doing projects larger than or far more detailed than, or both, than this one. The second way to compare two situations is to work not only with the current situation, but also with our future design. Tygron has effectively two time layers built into it. It has a current situation, the basis from which you begin your calculations. And future design basically means all of the modifications you would like to add to that. For example, it is possible to change the height of the weir as part of the future design. I have to do one calculation first to actually fill my panel. So we have a basic situation. The weir is configured with a certain height that has certain effects on the calculation. And as part of the future design, we have the possibility to change the height of the weir as a measure or as part of a plan for the future. Tygron will then recalculate the state of your project with that modification, creating new results, but you can then see the difference between those two results if you tell it to show those differences. For example, I have the surface loss value relative to datum result. I can say I want to show a difference option for this overlay that basically adds an additional mode to that overlay. There we go. Normal people just add it to all the ones, but yeah, whatever. It basically adds an additional mode which shows the difference between what you've calculated in the current situation and calculated as part of a future design. I can, as part of a future design, change the height of the weir. I can, for example, reduce it back to the 22 that you had originally. Tygron will then start a test run and recalculate the state of your project. So on top of your basic situation, it will add those modifications, in this case, changing the weir height, and then compute that new situation, leading to new results. Should have prepared 10 seconds more sentence there. So it's calculating right now, it's calculating the state of the project. A test run is now started. You can see that in the future design. Yep. And the overlay now features new information. I can place another measuring tool across this water line for the surface loss value results. And what we saw earlier was that the water level on this side was increasing far beyond what we saw on this side. Yeah, correct. Now they stay about equal. Now they form one continuously flowing section. You can also see that water is flowing due to the arrows which are visible in the weir itself. Yeah, the weir. So now we've created a new situation. We've changed the height of the weir. And we can also activate the difference mode of the overlay. And that allows us to see that there have been some changes in the 3D world based on what we have now done. I can create this line again. I can see the change, or I can see the new results in this overview. But as time progresses, as the simulation progresses, the coloring in the 3D world will slightly change. You will, for example, see some greener values here. That means it's the water level is slightly increased on this side. which is just the default legend. You can modify the legend. So this is a result type that shows with colors, and with some default values, you can tweak that to make the differences more pronounced. It will show the actual differences achieved through this change.
Yeah.
So that is also a way to see what is the effect of this Weir.
Yes, clear.
And by stopping the test run under the tab Future Design, I can stop the test run again. And now the situation is brought back to its original situation. I can again place my measuring line. And now the water levels will diverge again.
Yeah.
So that's about seeing differences. I think that is enough for you to handle seeing differences in the 3D world.
Yeah, but you only have difference in the surface water, but can you see it also in this groundwater? There is a groundwater level that you can see the difference between
Yes.
when the weir is up and down.
Yeah, you can see the same differences if you have the, or rather you can see the appropriate differences. If you add the difference option to, for example, the groundwater table as well, that changes the height, or the groundwater table is the height of the water in the underground. And if you activate the difference option, you change the setting of the weir, it will probably lead to slightly different results. Groundwater is always a bit slower than surface water.
Yeah.
And the difference overlay will also show those changes as well. I will emphasize, look at the legend, which the difference overlay is configured to. It has a number of colors and values predefined. You can change those if you want. And I recommend you do, because an increase or decrease of 5 meters of water is rare, to say the least.
It's a lot, yes.
So change these to an order of magnitude that are more appropriate for your case. For example, 2 centimeters, 5 centimeters. And maybe change the names or the colors to better fit what it means. I'm not sure if a lower water level or a higher water level or a lower or higher groundwater level is actually positive or negative, as the rendering implies. So those should be the tools for that part of your question.
Yeah,